Math 102, example 3.5.5. So we've looked at vertical asymptotes. Our other types are horizontal and oblique asymptotes. We usually look at them together because, as you can see, we are going to have 4 cases memorized. So how to tell which case we're in? We look at the degree of the numerator and then the degree of the denominator. So our first case, the numerator and the denominator have the same degree. So if I look down at example A here, 5x plus 2 over 2x minus 7, the numerator has degree 1. Remember, if there is no exponent, it is degree 1. And the denominator also has degree 1. So this is case 1. I like to number the cases just to help keep track. You do not need to know the numbers of the cases, though. So here, my horizontal asymptote, or HA for short, is the fraction which is the leading coefficients. So I'm going to write HA, and again, it is y equals, because it is a horizontal line, 5 over 2. Now, if I could reduce that, I would do so. This fraction does not reduce, though, so that is my answer. Now, we cannot have both a horizontal and an oblique asymptote. So because we have a horizontal asymptote, this one does not have an oblique asymptote. Now, let's use our calculator to help. So let's graph that function. And again, please notice I have parentheses around the entire numerator and parentheses around the entire denominator. Now, again, these are a little bit hard to tell graphically. I can hopefully look at the picture and at least tell approximately where this horizontal asymptote occurs, but it can be hard to tell for sure. So let's go back to y equals, and now as a second line, y2, let's graph that horizontal asymptote. And let's hit graph again. What is an asymptote graphically? This is where the original function, it's getting closer, 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 but it never touches it, and it never crosses it. It's a little hard to tell on the right-hand side, but hopefully it's a little easier to tell on the left. That is what's going on here. So again, the calculator will not tell you these directly, but if you graph it, it should display this asymptotic behavior. If it doesn't, that means I probably have the wrong asymptote. All right, that's my first case. Let's scroll that down so we can see our second case. So our second case, the denominator has the higher degree than the numerator. So if I look at B here, that numerator is degree 1, and the denominator is degree 2. So we are in this second case. Now, there is no computation involved in this case. It's pretty much just straight up memorization. Our horizontal asymptote is always just y equals 0. And again, just to be clear and thorough, there is no oblique asymptote here. Let me scroll that down a little bit so we can see our third case. This is probably our hardest case. The numerator is exactly 1 degree higher than the denominator. Generally, what's going to happen, as is happening in part C here, is our numerator is a quadratic, degree 2, and our denominator is a linear, degree 1. Because we are going to do synthetic division to this case to get that oblique asymptote. So, let's do synthetic division. Because there's an x in front of that number, I take the opposite, so positive 2, and then I put the coefficients to the right of that. So let's do our synthetic division. Now we will generally get a remainder, but we are going to ignore that remainder. My oblique asymptote is just the quotient. So my oblique asymptote is y equals x plus 3, 1x plus 3. And just to be thorough here, there is no horizontal asymptote. Once again, let's go ahead and graph this one so we can see it. So y1 is my actual function, and again, I've got parentheses around the numerator and then parentheses around the denominator. And then y2 is my oblique asymptote. So let's see what this looks like. So here's my function. There's the function. You can't see the right-hand side very well, but it is there. And then that diagonal line is our oblique asymptote. They're also sometimes called slant because it is generally a linear function. Now again, I can't see the right-hand side very well, but I can see the left-hand side. And if we look at that, it does look like it's getting closer, closer, closer. Again, that's what an asymptote should look like. So again, when I graph to check, I'm seeing if it's getting closer, closer, closer. If it isn't, that means I probably don't have the right asymptote. All right, we do have one final case, case number 4. Now, we don't see this case very often. The good news is it's fairly easy. So here, the numerator is 2 or more degrees higher than the denominator. So here on example D, that is what's happening. So again, this is case 4. And here, we do not have a horizontal asymptote. We do not have an oblique asymptote. We would still have a vertical asymptote. We are not looking for that for this particular example, though. So again, those are the 4 cases. And again, we can use our calculator to help check them, but we will need to have these cases memorized.